Welcome back. This is conic sections in polar coordinates. This is the last section for this module. This is the last section in chapter 10 that we will cover. So it starts off says there's a theorem. It says let F be a fixed point called the focus and L be a fixed line called the directrix in a plane. Let E be a fixed positive number called the eccentricity. The set of all points P in the plane such that the absolute value of P of F divided by the absolute value of PL is equal to the E, the eccentricity. That is, the ratio of the distance from F to the distance from L is constant. What's important is that you need to memorize this. If E is less than 1, I have an ellipse. If E is equal to 1, I have a parabola. If E is greater than 1, I have the hyperbola. So again, these are things we're supposed to know for the test, and it's just their distances. So here's another look at it, and it says, look, given some conic section, and I want to know if the eccentricity is equal to 1, then I could say that the distance from P to F is equal to the distance from P of L. It says if the point P has a polar coordinate r theta, because we care about it as in polar, then I know that the distance from P to F, right, is equal to R. P to F is here, and that's equal to my R. And the P to L, so from this point P to my line, my directrix, is equal to D minus R cosine theta. Well, where does that come from? Well, if this length here is R cosine theta, right? And then I know from here to here is the length of D. I only care about this length from here to here. So if I remove R cosine theta from D, that would give me the length from P to the directrix. That's where it's coming from. So that's the condition of PF divided by PL is equal to E, or PF is equal to EPL. R is equal to this. So what does this give me? Well, I could then go distribute. I could distribute. I get that. And I could put all my r's to one side. So r plus ER cosine theta is equal to ED. And then I can factor out my r. 1 plus E cosine theta is equal to ED. And then I can divide through and say R is equal to the ED over 1 plus E cosine theta, which is the general formula, where E is my eccentricity, D is my directrix, right? And so let's look at this. If I have these situations, what I want you to realize, cosine theta, the directrix is in terms of x on both of these. What's more interesting, that's plus, that's a positive directrix. That's a minus directrix. X and cosine, they work together. So that means sine would work with y's. And guess what? Looking at this, positive, negative, negative. Sine theta, directrix is y equals. I'm going to use that concept. So it's a really easy function to remember. One thing I'm going to ask that you always keep your, I don't want any complex values. I want everything to have whole numbers. All right. So we're going to work out some of these. It says, theorem, a polar equation of the form, right here, represents a conic section with eccentricity E. The conic is an ellipse if E is less than 1. Equals 1 means it's a parabola. And if E is greater than 1, it's a hyperbola. So I'm going to use this to build my equations. So here's the first one. E equals 1, that means it's a parabola. right? That's what that defines us. I have an x here, so that means I need a cosine theta, right? I have a negative here, so I want a negative in my function. My function again is r is equal to e times d all over 1 plus e cosine theta. Well, let's plug and play. And I'm not worried about the sign for up top. So e is a 1 times a 3 over 1 plus, whoop, not 1 plus, right? I just got to say it was a negative here. So I need 1 minus 1, because that's what e is, cosine theta. I can clean all this up. So my function, my equation for this polar is r is equal to 3 over 1 minus cosine theta. 1 minus cosine theta. It's that simple. Let's look at another one. Eccentricity is 1.5. If it's greater than 1, we said that's a hyperbola. Y, that means I'm dealing in sine. Positive for my function. So I know I'm using this function. I'm going to say r is equal to ed all over 1 plus e sine theta. So again, I plug it in. R is equal to, well, 1.5 is the same thing as 3 halves, right? That's equal to 1.5. So we're going to write that as 3 halves. My d is a 2. And then we have 1 plus 3 halves sine theta. All right. So that cleans up nicely to 3 over 1 plus 3 halves sine theta. But we don't want to deal with fractions. So I say r is equal to 3 over. I could pull a half out. If I pull a half out, I get 2 plus 3 sine theta. I'm going to put that half in the top, making it a 6 in the numerator. 2 plus 3 sine theta. That's the final answer. There are no fractions. There are no decimals. This is how I would expect you to answer the problems on the test. So e equals 3. All right, it's greater than 1, so e is greater than 1, hyperbola. X, that means a cosine, positive. So we're looking at r is equal to ed over 1 plus e cosine theta. So r is equal to 3 times 3 all over 1 plus 3 cosine theta. We're almost done. This cleans up nicely to r is equal to 9 over 1 plus 3 cosine theta. All right. So it's easy to find these equations in the conic section. And we identified the type. So now it's given E. I want to find E. This time I want to find what E is. And I want to identify the conic section and give the equation of the directrix. This is a problem I would ask you on the test. So first I'm going to fix the problem so I can see what I have. I'm glad I see I have a minus, so I know some stuff there. I have sine, so I know I'm dealing with y's. Right? So I have in the numerator 4. The standard is a 1 here, so let me factor out a 5. 1 minus 4/5 sine theta. I'm going to bring that 5 up. So now I have 4/5 all over 1 minus 4/5 sine theta. That's what r is equal to. But that's E there, isn't it? So E is equal to 4/5. And if that's the case, 4/5 less than 1, therefore, what is it? Correct, an ellipse. I know that this part here is ED. So I know that ED is equal to 4/5. Right? So what is my directrix? Well, I know E is 4/5. D has to equal 1. But I need to pay attention to something. It's not just equal to 1. Remember, this is a minus in front. So the equation of my directrix is a y, right, because we're dealing with sine. Y is equal to -1. That's the answer for that part. I answered the ellipse, and I answered the what is the eccentricity. So I've gone through and I've given answers to everything that they asked for. This is how I would expect you to do these problems on your test. There will be a problem like this on your test. So now it says find E, identify the conic section, and give the equation of the directrix. So again, standard would be R is equal to ED over 1 plus E sine theta. So I'm going to have R is equal to 1 over, factor out the 2, right? Bring the 2 up top. Let's identify things. E is equal to 1/2. That was the first thing. E, which is less than 1, so it's an ellipse. Wow, I don't know who taught me how to write. So I answered these two parts. I need the equation of the directrix. I see that I have a sine, so I know my equation will be a y. And I see a plus, so I know it's a positive value for my directrix. So the directrix we have to find. So let's do that. We have ED is equal to 1/2. We know E is 1/2, so we have 1/2 is equal to 1/2 ED. So D is equal to 1/2. So my directrix equation, Y is equal to a positive 1/2. Oops, sorry, positive 1. I can do math. Right, when I multiply through by the 1/2 or divide through by 1/2, D is equal to 1. So Y is equal to 1. All right, let's do another problem. So now we want to again find the E, identify the conic section, and give the equation of the directrix. And standard form would be ED over 1 plus E sine theta. So we have a plus, that's good. So we know the directrix will have a positive value. We know it will be in terms of Y. And we know that 2 is equal to ED. Well, we think that until we finish this problem. So let's figure out what it is, because we don't have a 1 in front. I need to factor out a 3. So I get 1 plus sine theta, like this. And then I'm going to bring the 3 up. So again, R is equal to 2/3, 1 plus sine theta. So E looks like it's equal to 1. And that means I have a parabola. So I answered 2 questions. I know that ED is equal to 2/3, and E is equal to 1. So D is equal to 2/3. My equation of the directrix, Y is equal to 2/3, and it's a positive 2/3. Let's get another problem. Again, we want to look at the standard form of this, which is 1 minus E cosine theta. I have a minus, so my directrix will have a negative value. Cosine, which means my directrix will be in terms of x. So I'm going to get this into a standard looking form. Factoring out the 2, I get 1 minus 2 cosine theta. I'll bring that 2 up. 1 minus 2 cosine theta. So we know that E is equal to 2, according to this, right? That's my E value. That's greater than 1, so I have a hyperbola. I've answered 2 parts of my problem. I know that ED is equal to 5 halves. Well, 2 times D has to equal to 5 halves then, doesn't it? Or D is equal to 5 fourths. So the equation, right, because I divided through by 2, the equation for my directrix is X, because I have cosine, is equal to minus 5 fourths, because there's a minus here. And again, it's an equation, so I have to say X equals or Y equals. We're almost done. Let's look at the next problem. All right, hold on for a second. All right, let's think about this for a second. We know that the standard form of this R is equal to ED over 1 plus E cosine theta. There's a plus, so my directrix is positive. It's cosine, so it's in terms of X. So let's work on the problem. R is equal to, factoring out a 6 from here, 1 plus 1/3 cosine theta. Bringing up that 6, I get 9 over 6, which can reduce to 3 halves. 1 plus 1/3 cosine theta. So what do we know? E is equal to 1/3, which is less than 1. It's an ellipse. So I answered 2 parts of my problem. We know that ED is equal to 3 halves, right? And then we know that E is 1/3, so we got 1/3. D is equal to 3 halves, or D is equal to 9 halves, right? Multiply both sides by 3. So the equation of the directrix, we're in cosine, I believe, cosine, X equals positive value, 9 halves. That's the equation of the directrix. Let's look at one more problem. Again, R is equal to ED over 1 minus E cosine theta. Negative directrix, terms of X. So factor out the 4. Bring it up top. E is equal to 2. That's greater than 1. That's a hyperbola. So I've answered 2 parts. I know that ED is equal to 3 fourths, but we already know what E is. It's equal to 2. So 2D is equal to 3 fourths. I multiply everything through by half or divide by 2, so D has to equal 3/8. The directrix, the equation of the directrix, it's in terms of X, so X is equal to subtract. Again, I do a subtraction symbol because of this part. And it's equal to minus 3/8. So that is the last part of chapter 10. So we finished it. It's the last note that we have in here. So this completes the module, and I hope you enjoyed it. Thank you very much for your time, and I will see you to class. Apparently, this is the shortest one we've done. It's under 20 minutes. Thank you very much.